Okay, so some things that we may have noticed so far. First of all, it's not really necessary to draw the function, especially if we are using our f of x function and our calculator table to generate the y values for our t table, and then we just plug in the numbers from our t table into our sum. The second thing is that the more rectangles we create, the more work we have to do. And again, it's not hard work, it's just adding and multiplying, but there are more things to write down. In each case, the base is the same, the base being the width of the rectangle. And so that allows us to factor it out, and that's the reason why we have the b minus a over n out front of our sum. But in each case, that's actually just simply being multiplied by the width so that we have individual rectangular areas that we're adding up. Number 4, the only difference between the left hand and right hand sums is the first and last height. So for the left hand sums, we leave off the last one, and for the right hand sums, we leave off the first one. But let's think about intuitively what happens in terms of our approximations. When is it going to be an underestimate? When is it going to be an overestimate? So here we have a table in example 4. They want us to give a hypothesis for when we would get an under or overestimate depending upon which type of sum and the function's behavior. So for me, I do like to draw pictures, so I'm going to sketch each of these situations and then think about what's going on in terms of left and right hand functions. Okay, so I have sketched the 4 different situations: concave up and increasing, concave up and decreasing, concave down and increasing, concave down and decreasing. So now let me just sketch in the different types of rectangles. Now, looking at my left hand sum in the situation of concave up and increasing, my left hand sum is actually, my rectangle's a little off, but my left hand sum is under the curve, and so that's an under estimate. Now my right hand sum is actually over the curve, so we have an overestimate. Now for concave up but decreasing, my right hand sum is under the curve, so that's an underestimate, and my left hand sum is over the curve, so that's an overestimate. For concave down and increasing, the left hand sum, so that's where the left corner touches the graph, that is an underestimate. And the right hand sum, where the right corner touches the function, that is an overestimate. Likewise, for concave down decreasing, the left hand sum, where the left corner touches the function, is an overestimate. And the right hand sum, where the right corner touches the function, that is an underestimate.